Good evening, students. Welcome to Dimans's class. Today, as you can see, we are going to discuss about midpoint theorem. We are going to discuss about midpoint theorem. Means, theorem is already written here. I'll come to it. But before I start, as usual, I would request you to see the video fully from the very beginning to the end. Don't skip this video, otherwise you won't be able to understand. And please share, subscribe this video with your friends as much as possible. And please don't forget to subscribe this channel, Dimans's class. Okay? Now, let us start. Midpoint theorem. See, the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and equal to half of it. This is the midpoint theorem. It's written here. Sir, ऊपर से निकल गया, टेंजेंट होकर निकल गया. डोंट वरी, टेंजेंट नहीं होगा, पूरा एकदम इंटरसेप्ट करेगा अंदर. वो हम समझा रहे हैं, मैं हूं ना. तो सी, लेट अस स्टार्ट विद अ डायग्राम. सी, फर्स्ट, a line segment joining the midpoints of any two sides of a triangle. So first of all, we need a triangle. See, this is a triangle A, B, C. Let this be a triangle. And the line segment joining the midpoints of any two sides. Let's take this AB and AC two sides. So let this be the midpoint and this be the midpoint. These are the two midpoints. Let D be the midpoint on AB and E be the midpoint on AC. And DE is joined. Now here we have to prove that this line is parallel to this line. See, the line segment joining the midpoints, the line segment formed DE is the line segment joining the midpoints of any two sides of a triangle, is parallel to the third side. That means this will be parallel to this and equal to half of it, and DE is equal to half of BC. The two things here we have to prove. One is DE parallel to BC, and the other one is DE is equal to half of BC. These two things we have to prove. So for this, we have to start with proper stepping. So what are we given? We are given in triangle ABC, D and E are the midpoints of AB and AC respectively. Okay, now and BE is drawn. Means DE is been drawn. Okay. Now RTP. Number one, DE is parallel to BC. Third side, parallel to the third side. So DE is parallel to BC. Number one. Number two, and equal to half of it, means DE is equal to half of BC, equal to half of the third side. These are the things we have to prove. So for this, a little bit space problem has occurred. So let me write this little bit this side. RTP. Number one, DE is parallel to BC. Number two, DE is equal to half of BC. Now why I said so? Because we have to do some construction. Here we have to draw a line CF, suppose, as if CF is parallel, this is F, CF is parallel to BD, okay, and DE is extended to F. DE is extended to F. Okay. So here, construction. CF is drawn such that CF is parallel to BD and DE is extended to F. DE is extended to F. This was the construction. Now let us start proving. Now what do we need to prove? We need to prove that this is parallel to this. So for that, my dear students, if we can prove that these two triangles are congruent, okay, if these two lines are congruent, triangles are congruent, then in that case what will happen? This will be equal to this, means CF will be equal to AD by CPCT, corresponding parts of congruent triangles, and this is already equal to this because D is the midpoint. Okay, so this, as because this is equal to this and this is equal to this, that means automatically these two lines will become equal. And if these two lines are equal, and we have drawn them as parallel by construction, CF is drawn such that CF is parallel to BD, So therefore, the quadrilateral formed between two equal and parallel lines is always a parallelogram. So that means BCFD becomes a parallelogram, and hence DF is parallel to BC. First part is proved. This I am explaining, I'll do it, don't worry. Next, we have to prove that this is half of this. So in that case, what will happen? We know, as because this is a parallelogram, so DF is equal to BC and DE is half of DF. So naturally, DE is half of DF, that means D is half of BC again. So let us start. In triangle AED, and triangle CFE, what we can see, angle A is equal to angle C. Why? Interior alternate angles. Why? Because see, this line is parallel to this line. By construction, we have already said that CF is drawn such that CF is parallel to BD. CF is parallel to BD means CF is parallel to AD. Okay? So that means this angle is equal to this angle. Now, E is the midpoint, so AE is equal to EC. AE is equal to EC. Why? Since E is the midpoint. Of AC that is given in the question, which we are going to prove. And then finally, angle AED is equal to angle FEC. Why, sir? Because vertically opposite angles I have written in short. You please try to write the full form. If you write Bhua, your marks will become Dhua. So be careful. Okay. Now, by angle side angle rule, triangle AED is congruent to triangle CEF. So naturally, therefore, AD is equal to CF. Why, sir? CP, CT. Corresponding parts of congruent triangles. This side is equal to this side. We have proved. But AD is equal to BD. So therefore, what happens? If AD is equal to BD, definitely BD is equal to CF. Now we know BD is equal to CF, we have proved, and BD is parallel to CF. See here, BD is parallel to CF. Therefore, so BCFD is a parallelogram. Hence, DE is parallel to BC. So therefore, DE is parallel to BC. This proves number one. This proves number one. Now remains second part. In second part, we know DF is equal to BC. Why, sir? Since BCFD is a parallelogram, opposite sides of a parallelogram are always equal. So DF is equal to BC. Okay. Or DF. So here 2D, in place of DF we can write 2DE. In place of DF we can say 2DE. Why? Because DE is equal to EF. 2DE is equal to BC. Since DE is equal to EF, CPCT. Means, as because these two triangles are congruent, so naturally this is equal to this. So this is equal to this. So in place of DF, we can write 2DE. In place of DF, we can write 2DE. Or DE is equal to half. This 2 goes this side, half BC. DE is equal to half BC. This proves number 2. Okay, students. So this was midpoint theorem, and in midpoint theorem, two things we have to prove. We have to keep in mind that if this is the triangle, these are the two sides of the triangle, and if the midpoints of these two sides are joined, then this line so formed is parallel to the third side of the triangle. Okay? As well as this line so formed on top is half of the third side. Clear, students? I hope now it is very clear to you all. So you can do the sums concerned with this, all those sums concerned with this midpoint theorem independently. If you find any problem, please don't feel shy to write in the comment section. I will definitely answer your questions. Okay? So for the time being and for the next video, good night. See you.